Hello everybody. Welcome to this lecture on Boolean functions represented in the form of truth table. So in the previous lecture we have already seen what a Boolean function is. Now let's see how we can represent a Boolean function in the form of a truth table. So let me explain this with the help of this example. So I have a Boolean function f out here which consists of three terms: x dash y dash z plus x dash yz plus x y dash. So this is a three variable function. So it can be written also as f x y z. So let us see how we can represent this in the form of a truth table. So this is my truth table. We are a part of it. So here we have listed out the variables x, y and z. So we have listed them out in this order as x, y and z. So the values that can be taken by x, y and z, so these are three variables, so it can take a total of 2 to the power 3, which is 8 possible values. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. So if you look at this, this is nothing but the binary representation of 0, 1, 2, 3, 4, 5, 6 and 7. So from 0 to 7, if you write the binary representations in three variables or up to three terms, then this is what you get. Okay, so this is how you can remember what values to put out here. Now we will write down the various values of the term of the function. So my function was x dash y dash z plus x dash yz plus x y dash. So here I need x dash, I need y dash. I don't need z dash. There is no term with the literal z dash. Only z is there. Then I will find out what is x dash y dash z. Another term I'll find is what is y x dash y and z. And the third term I'll find is x y dash. So this is the end of all this. All these are ends. So I will be able to get a value 1 for this if x dash is 1, y dash is 1 and z is 1. Similarly, for the second term, I will get a 1 in the truth table if x dash is 1, y is 1 and z is 1. Same for the third term. I'll get a 1 here if x is 1 and y dash is 1. And then finally, it is the OR of all these terms. So if in the truth table I get 1 here or here or here, my output would be a 1. So let us construct the table. So first, just for the ease of use, because I'm writing it for the first time, so let me just have one more column, two more columns for x dash and y dash. So x here is 0, so x dash would be 1. All four, first 4 would be 1s. Last 4 was 1 here, it will be 0 here. The complement. Same for y. Y first 2 0, then 1 1. So 0 will become 1. This 1 will become 0. Then another 2 1s and another 2 zeros. So x dash and y dash I already have. Now my terms were x dash, y dash and z. Okay. And then my second term was x dash, y and z. Y, z. And my third term was x, y dash. X, y dash. And finally, I need an OR of this to get f. Let me just remove this part. So my f is a OR of these three columns in red. So first let me find out what is x dash, y dash, z. So as I said, the result would be a 1 if all three are 1. That means x dash is 1. Okay, yes, it is 1. Y dash is 1, yes. But z is 0. So the result here would be a 0. For the second term also, both are 1. What about z? Yes, z is also a 1. So it's a 1 here. Next, here y dash I get a 0. So the moment I get a 0, I don't have to look at the others because I need all of them to be 1. So it's a 0. Here also I have y dash is 0, so 0. Here I have all four, in the remaining 4, in all these remaining 4, the first x dash is 0, so result is going to be zeros. Let us look at the second term now. X dash y z. So in x dash y z, I'm going to look at x dash y and z. All three must be 1. So here in the first itself we find y and z is 0. So this is 0. Second one also y is 0. So 0. Third one z is 0. So 0. In the fourth one I have x dash is 1. Y is 1. Z is 1. So the result is a 1. For the next one, y and z are zeros, so result is 0. Then again, these two are also zeros, so in all of these, the last 4, x dash is 0, so all these would be zeros. The last term is x, y dash. So x and y dash, that means, let me use a different color, x and y dash. These two columns we have to match. So both are, one is 0, one is 1. So this is a 0. Then this is 0, this is 1. So it's a 0. Again here you see x is there. So x, all 4 are zeros. So we don't have to look everywhere. So all are zeros. Remaining 4, x is 1. We have to look at y dash. Is y dash 1? Here, yes, y dash is 1. So I get a 1. Here also y dash is 1. So I get a 1. But in these two, y dash is 0. So I get a 0. Okay. Now, I have the three individual terms and I need the last term, which is f. So I look at the individual columns. So first is 0, second is 0, third is 0. So what I need, it's an OR of all three. It's an OR. This is a plus of all these terms. That means it's an OR. Any one must be 1. So here all three are 0, so result is 0. Here first term is 1, so it's a 1. Here all three are 0, so 0. Here second term is a 1, so it's a 1. In the next row, this is 1, so result is 1. Here this is 1, so result is 1. Here all three are zeros, so 0. Last row also all threes are 0, so we have 0. So you can see here that the function f can be represented. This is the truth table for the function f. Now you may, as you get used to this, you don't have to write down individual columns like I have. Okay, as you become expert, you don't have to make individual columns. But okay, for the beginning, you can always make individual columns for the different terms and then find the final function. So this is how we can represent a Boolean function in the form of a truth table.